Hi everyone, this is K Devender Reddy, Assistant Professor in Department of Electrical Engineering. In this video, we are going to discuss about power developed by Salient pole synchronous machine and power angle characteristics curve for synchronous machine. Let us assume the armature resistance of the alternator is neglected and the developed power of alternator is equal to the output power, and in the developed output power or phasor output power of the machine is equal to VI cos pi watts. So let us say I am showing the phasor diagram for a Salient pole alternator by neglecting the armature resistance. So here we know, for in the case of the two reaction theory, the armature current have two components. One is the direct axis component current as well as the quadrature axis component current, that is ID and IQ. Similarly, armature reaction the reactance of the alternator also having the two components, that is the direct axis component XT as well as the quadrature axis component XQ. And similarly, the field MMF as well as the armature reaction MMF also having the two components along with the direct axis quantity as well as the quadrature axis quantity. We can analyze the machine performance into the direct axis as well as the quadrature axis because of the reluctance offered by the Salient pole alternator is non-uniform. It is the reluctance offered by the Salient pole alternator along the D axis is very less than the reluctance offered along with the Q axis, that is called the quadrature axis. So let us here V as a supply, V is the terminal voltage, and armature current has two components, that is direct axis component as well as the quadrature axis component. The vector combination of these two will gives you IA, and the IA current lags the voltage by phase angle called phi, right? Next, from V we will draw a line that is called drop due to direct axis reactance, that is IDXT, which is in quadrature with ID current vector. Similarly, the drop due to quadrature axis will be a quadrature axis, that is a perpendicular vector for IQ, and the vector addition of these, the E0 is equal to E0 vector is equal to V vector plus drop due to direct axis component, that is IDXT, plus drop due to quadrature axis component, that is IQ and XQ, where I am neglecting the drop due to armature winding resistance, that is equal to 0, that is IARE drop is 0. So this phasor diagram, from the phasor diagram we will derive the expression for power developed by synchronous generator. IA cos pi is equal to, let us, I am assuming it is equation number 1, that is IQ cos del plus ID sin del, and E0 is equal to V cos del plus IDXT. From this you can write the expression for direct axis component current ID, which is equal to E0 minus V cos del by XT, that is assuming it is equation number 2. Similarly, you can also write down the expression for quadrature axis current, that is V sin del is equal to IQ XQ, and IQ is equal to V sin del by XQ. Let us assume this is equation number 3. And developed power is equal to PD, which is equal to V times of I, that is V times of IA cos pi. PD is equal to, we already defined it, V times of IA cos pi, where IA is equal to, IA cos phi is equal to, that is equation number 1, IQ cos del plus ID sin del. So substitute this one in this expression, we will get PD is equal to V times of IQ cos del plus ID sin del. So substitute IQ value as well as the ID value from equation number 2 and 3 in this expression. Let us, I am naming as equation number 4. Substitute equation number 2 and equation number 3. Substitute equation number 2 and equation number 3 in equation number 4. We will get PD is equal to V times of IQ is replaced by equation number 3, that is V sin del by XQ into cos del plus id is equal to E naught minus V cos del by xt into sin del. So simplified, E naught V by xt, E naught into V by xt into sin del. Later V terms, V into V square, take it as a common, sin del cos del by x cube minus sin del cos del by xt. So V square by 2, it is V square by 2 into xt minus x cube by xt into x cube into sin 2 del we can write. So sin del cos del, take it as a common, that is xt minus x cube by, so you can write it here, E naught V by xt into sin del plus V square into, take it as x cube and xd, this is xd minus x cube into sin del into cos del. So simplify this, you will get V square by 2, that is sin 2 del by 2, V square by 2 into xd minus x cube by sin 2 del, that is equal to expression for power developed, PD is equal to E naught V by xd sin del into V square by 2 into xt minus x cube by xd into x cube into sin 2 del. And finally, this is equation number 5. Equation number 5, that will gives you the two terms. The term 1 is the E naught V by xt into sin del. Second term will be V square into xt minus x cube by 2 times of xt into x cube into sin 2 del. So the second term represents the power due to saliency, we can also call it as reluctance power. So this is a per phase quantity. If it is a 3-phase alternator, you can multiply with 3, you will get total power developed by alternator, right? So we have to note down the following points. So first point is, if there is no saliency, that we already discussed, if there is no saliency, the second term of the equation number 5 leads to 0, because if there is no saliency, xd and x cube both are equal, so this term will becomes 0 and developed power is equal to only first term of equation number 5, that is E naught V by xt into sin del per phase quantity. This is equation number 6. Similarly, so the equation number 6 represents the power developed by, there is no saliency means it is a cylindrical rotor structure. So the output of the cylindrical rotor structure is, that is equation number 6. Now from equation number 5, the second term of equation number 5 represents effect of salient poles. So it represents the reluctance power. So PD is equal to V square into xt minus x cube by 2 times of xt into x cube into sin 2 del per phase quantity represents the power due to saliency. If E is equal to 0, that is if the excitation is 0, the power obtained with a 0 excitation is called as a reluctance power. Reluctance power will not be depending on excitation of the alternator. It is independent of the excitation of alternator. This is all about the derivative part for the power developed by synchronous salient pole synchronous alternator. Similarly, we will discuss about the importance of power angle curve. So the power angle curve, nothing but it is a graphical representation of the power developed or output power with respect to the load angle, or we can also call it as a power angle of the alternator. So the electrical power output we can represent it with EV by XS sin del, and where E is the nothing but excitation, V is the terminal voltage, XS is the synchronous reactance, and del represents the load angle of the alternator. If you draw a graph between the excitation power with respect to the load angle, so it will give the power angle characteristics curve of the synchronous machine. So if you observe the characteristics graph between del between 0 to 90, it is equal to 90 degree, up to in between 0 to 90 degree, it is progressively increasing the power output. And when it attains the 90 degree, del attains the 90 degree, the developed power also reaches to the maximum case, the maximum power will develop. So after del increases 90 degree, after reaching the 90 degree point, it is decreasing in nature. The developed power output of the synchronous machine is decreasing because of the poles are falls back, that it will loses the saliency. That means if the alternator are get connected in parallel, the alternator is get connected in parallel, if you are further increasing the load on the alternator, the poles of the alternator will loses the saliency. That means it will loses the synchronism, and it is comes into the rest condition. So if you are increasing the alternator load further by del angle 90 degree, it will decreases the output power. That means your the mechanical input power is greater than your electrical output power. So the efficiency of the machine will be gradually decreases if your del greater than 90 degrees. This is about the power angle characteristics curve of synchronous machine. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.